Hello and welcome to my first video in a series of videos that will be covering the various core problems and lessons and review preview problems found in the CPM Algebra 2 textbook. This video is going to cover the lesson 111 core problems, that being problem 1-1 and 1-2 in the CPM Algebra 2 book. So the first problem is called building with yarn. The idea of this is with people at your table, your teacher will give you a single loop or yarn, usually 6 feet in measure, and you will need to take turns making the shapes below with your group. The idea is that every group member needs to be touching the string in some form or fashion. You can make them in any order, and then your teacher needs to check off that you were able to correctly create the shapes. You cannot use, the table to help. You cannot use tape. It has to be everyone's. The three-dimensional objects actually have to have a height and a depth to them. Okay, the only two-dimensional object is the 5-point star on the right. So this one, it takes a lot of teamwork. The idea is to start to emphasize teamwork and working together to solve problems. And that is a big part of this course. So if you haven't done this, pause the video and try this problem out if you have the materials in your group with you. If not, just advance to the next problem. Big part of this textbook is this idea of cooperative teamwork. So you have some roles each group is supposed to have been given. Usually there's 4 to a group or a table in a classroom. The resource manager makes sure that everybody at their table has the necessary materials, such as the yarn for the problem previously or the resource page for the next problem. Ask the teacher a question when the entire team is stuck. The idea would be helping each other out before asking the teacher for help. And if no one can answer the question, has an idea or is stuck, then this person goes and gets that teacher and asks them that question. And then delegates tasks and makes sure everyone helps put things away. Facilitator tries to start the conversations by reading the questions aloud and asking questions about prompting people to start thinking about how to solve the problem, and doesn't allow people to move on unless everyone else understands. In this course, you really want to work on having your team, making sure everyone at the team understands what is going on, how the questions are supposed to be answered before moving on. Third person is reporter. Now this is kind of making sure people have access to the resources and is prepared to take and share notes. However, everyone should be documenting their own ideas, calculations, strategies in this class, not just this person, but they usually will share out to the class when the opportunity is provided. Then the task manager, keeps the team on task. You don't want to talk outside of your group of students. That's really hard to start off with. So task manager is supposed to help keep the team on task and remind others in the group to not talk to people outside of their table. And they keep track of the time. There's only so much time in a period. And so we need to make sure we get done on time and we have enough time to clean up. So the task manager is that person. If you have any extra questions about your roles and within your group or how they're assigned, talk to your teacher. The second problem is function machines. So if you took the Algebra 1 CPM course, and this is a familiar concept. If not, this is a brand new idea, and this does come up very much in the initial chapters when it comes to the review, preview / homework problems. So you were given 4 functions. So we got F, G, H, and K. And the idea is whenever you take the input of one function, it becomes, when you put something into a function and calculate that result, the result of that becomes the input of the next function. So my idea is to stack these in order or to order these functions in such a way that when I start with a certain input and every function has had its effect on the various inputs calculated, therefore, we should get a particular output. So the idea of this is to kind of think about what values make sense, what values don't. Can I predict what each function will give me in and give me out, or what values I can put in each function? And that's kind of going to kind of help me to get my order here. So what I want to do is I want to start with a 6 up here. So I want to put some function in here and have a 6 initially start. Then I want to come out with an 11. So one thing we note is that g of x only gives me negative outputs. So that negative sign is going to result in this function always becoming negative, because when you square anything, you get a positive result. So g of x will always be negative. So g of x can't be last in this rule, because in this order, because we want a positive 11. So g of x has to be somewhere else. I also know that 2 to the x as an h of x, that's an exponential function. There's no way I can make that equal 11, so that can't be last either. So I know those can't be last, but they can be anywhere else. So let's start plugging some stuff in. So let's try g of x first. Okay, so let's see what we get when we plug 6 into g of x. So I get 6 minus 2 is 4. 4 squared is 16. But that negative makes it negative 16. So I get a negative 16 out. Okay. So now that will become the input of the next rule I use. And so my thinking is that the square root function is going to give me, can take big numbers and make that 11. So maybe that's my last one. And then if I put that in next, if I use h of x next, that'll give me a very small number because I'm negative exponent. So I'm going to try k next because I got a negative in there, and negative x over 2. So if I put that 16 up there, that'd be positive. And let's just see what we get here. So when I plug negative 16 into k of x, so we get negative 16 is 16. 16 over 2 is 8. 8 minus 1 is 7. So I get a 7 there. So I've used g and k. And so I'm thinking that I'm going to have to use h of x next because I can't use h of x last. So I'm thinking h of x is going to go next. So I'm going to plug 7 into here. So we get 2 to the power of 7. 2 to the 7th is 128. Minus 7 is 121. Then I'm going to plug 121 in for f of x, which means the last function, and I know the square root of 121 is 11. So the correct order is g of x, k of x, h of x, and f of x. Okay, so there's a second part to this problem. Here it is. You do the same idea, but you're going to start with 64, and you want a final output of 131,065. So if you haven't done this already, pause this video and work this out. See what you come up with. Okay, so I know I need a very large number out at the very end. So I want through 131,065. The only thing that's giving me a very large number is h of x. So I know h of x has to go last. Okay. It has to be the last one I need. So the idea would be to kind of figure out which functions I can use beyond that. So I want to start with the 64. So I think g of x will give me too big of a number and negative. K of x, I don't know if that's quite going to do it. So I'm going to start with f of x, because f of x is a square root, and 64 square roots very nicely. So let's see what we get. So f of x, 64 and f of x gives me 8. Okay. And so the next one I'm going to try is g, because if I do g then k, I got a negative output for g, then I can put that negative into k and get a positive, and that's something I can plug into h of x. Remember, I don't want a negative input in for h, which g of x would give me, so I think g of x has to go next. So let's try this out. So 8 minus 2 is 6. 6 squared is 36, but that makes it a negative 36. Now let's put k of x next. I'm going to put negative 36 into it. Negative 36 is 36. 36 divided by 2 is 18. 18 minus 1 is 17. Oops, no, I don't want to do that. Sorry. Let me erase that. So not 17 there, 17's here. And now let's confirm. If I plug 17 into 2 to the x minus 7, so we get 2 to the 17th power is 131,072 minus 7 is what I want. So the correct order for B is f of x, g of x, k of x, and h of x. This idea of stacked function machines is really important for later in this course. Now, the last thing we should always look at in some of these lessons is this section on math notes. So the math notes section goes over key ideas, definitions, strategies throughout the course. It's recommended you read it. Now, this is functions. And so it defines that a relationship between inputs and outputs is a function if there's exactly one output for each input. If I had to, I would make sure that you knew that definition. A lot of Algebra 2 is about functions, and so you're going to be asked a lot to determine if things are functions or not. So I'm going to highlight this really badly, that you need to know that moving forward. Okay. Functions are often written as y equals something involving x. X is always the input, y is the output. So over here is examples of different representations of a function. So this is the equation format. This is a table where we can plug these inputs into the rule of the equation and get their outputs. And then the graph is a visual representation of these pairs of inputs and outputs. Another thing you want to understand and know is the idea of dependent versus independent variables, which does come up. So because in this example, the output or y is always dependent upon the value plugged in for x, y is always called the dependent variable and x is the independent variable. Another thing goes over is this idea of function notation, something you should have learned in Algebra 1 or seen before this course. So the idea is the f in front of the parentheses, that's the name of the function, is not a variable, you're not multiplying. Okay, this tells you so the f is the name of the rule the function is equal to, and x is just denoting the input value being used. So a lot of times in this course, you're going to be asked to evaluate things with function notation. So it would be really important to go forward and kind of remind ourselves what function notation is and how to use it appropriately. Okay, another big idea in this course is the idea of domain and range. So again, some definitions we want to know. So I'd highlight this. The set of all inputs for which there's an output is called the domain. And the set of all possible outputs is called the range. So you really want to note those. In the previous slide, since you could put any x value into those quadratic equations and get an output, we would say the domain is all real numbers because any number can be put into the function for x. And if you noted on the graph in the table, we only got values of y that are equal to 0 or greater than it. So we say the range is that all y's have to be greater than 0, including 0. So those are things that's a big idea in this course. Then lastly, we want to talk about, and it gives us a good idea of what a non-function is. So x squared plus y squared equals 1 is not a function because there are two values of y outputs for some of the x out values. So you can see how For x 0 and 0, we get -1 and 1. That can't happen in a function. And you can see that the circle here definitely fails what we call the vertical line test. So I can draw a vertical line through this graph and it intersects in two places. That is a way of determining if a graph is a function. In this case, since the vertical line intersects the graph of the circle more than twice, this would not be a function. So hopefully this video gives you some insight and helps you out with this initial lesson in the CPM Algebra 2 textbook or curriculum or course you're in. If you found this video useful, I'd appreciate it if you could like the video. If you would like to get updates on more videos as I post them relating to CPM stuff, subscribe to my channel. Thanks.